We move from quantum cryptography to 3D atlas and interesting technologies, space travel, and so much more. This is going to be a really, really interesting podcast that we will now make available to you at regular intervals. Who are you and what do you do?
What do you even want here? Yeah, that's good. A lot in the field of satellite navigation and satellite communication, and especially in the niche of quantum communication. That's what I'm working on professionally and thematically now. I also have a strong background in cybersecurity. Honestly, what I'd also really like to talk about is this whole topic because it's just super relevant right now. By the way, if you think of the point, just jump in, please. It's this whole topic of the 3D atlas because you could also consider it as a satellite in some way if we really think outside the box. But no, seriously, jokes aside, I find the 3D atlas super exciting. It was just recently, I think not even a week ago or about a week ago. Super interesting topic. A lot has happened. And 3D atlas, I think it would be kind of fun if we took a closer look at it, if you're up for it too.
Sure, absolutely.
Because the 3D atlas shows some very interesting anomalies. I actually took a look at Avi Loeb's paper on this, and I can really recommend it. It's, I think, 7 or 8 pages, and it's actually pretty easy to read if you've read papers before. So that's definitely a recommendation from me. Absolutely.
I'll post it in the video description in case you want to check it out.
That's definitely going in the video description. Check it out. The authors are from Avi Loeb's research group, not Avi Loeb himself, if we're correct. In any case, like some really unusual things have shown up in the 3D atlas that definitely need to be discussed. And I also find it really interesting to talk about it because on the one hand, we have the issue that we have a lot of anomalies and unusual features that we really shouldn't be seeing like this. We have anomalies in the orbit. We have a really strange non-gravitational acceleration. Then we also have something interesting regarding intelligence, like the approach to planets, which is actually relatively rare. Size and mass are also fascinating, and we absolutely have to talk about the blue as well. I find that really exciting too. Honestly, I would just like to talk a bit about these anomalies or focus a bit on these anomalies because they really are. They're actually quite significant. Just to clarify, not everything is immediately extraterrestrial, though that would be nice. Sometimes I privately think to myself, oh, it would be great if they would show something now. Then maybe we would have solved a few problems, or maybe not. No idea, it depends. But if we really take a look at the anomalies from this 3I atlas, a hypothesis about extraterrestrial technology would actually be proposed. And if we look at the anomaly of the orbital period, that is this orbital plane, then we're talking about an anomaly of the orbital plane. So normally you have to imagine it like this. When something enters interstellar space, at first you have three-dimensional chaos. And an object coming from outside should approach our solar system from any direction, at any inclination to the ecliptic. That is the approximate plane in which our planet orbits, so to speak. So you could also think of the ecliptic as a kind of cosmic. Earlier we discussed roads, so think of it as a cosmic highway in our solar system. And here we have a super extreme tilt, which is really unusual. So for one thing, 3I Atlas is on a hyperbolic trajectory and is traveling at a speed of, what was it again? 60 kilometers per second outside the solar system, something like that. So relatively fast. But what's really unusual is actually that its orbital plane is only minimally inclined to the ecliptic by about 5 degrees or so. And although the movement is retrograde, we can say the inclination is actually 175 degrees. The orientation itself is quite striking because the probability of such a random, nearly perfect alignment with the orbital plane or the orbital angular momentum vector with Earth is incredibly low. It's 0.2%. And that's ultimately what we as scientists and engineers always try to point out. There's something abnormal here, something doesn't fit. Because the data simply tells us, hey, that actually shouldn't happen. It's so clear it can still happen, but it's just so unlikely. That's one of the most important considerations for why people even said, let's tackle this now. We're tackling this now. and maybe you pick a few other topics related to this object or take a closer look at this object again, what might not fit there yet. Now, when we discuss anomalies, as mentioned earlier, we cover topics like orbits, non-gravitational acceleration, and plumes. Then there's a precedent, maybe some of you still remember, because we had this one, Oumuamua. I'm definitely pronouncing it wrong. Muamua, yes, exactly. The idea that interstellar visitors experience non-gravitational forces is nothing new. So already the first discovered interstellar guest, which we just showed, or Oumuamua, so to speak, showed nothing other than a statistically significant non-gravitational acceleration. And that was the puzzle back then. This acceleration was present, even though there were no spectroscopic signs of such a cometary outgassing. So the outgassing didn't produce a visible comet tail that could have provided the necessary recoil. And some experts considered this so unusual that a discussion arose about whether it could even be solar radiation pressure acting on extremely thin photonic sails. Extremely thin photonic sails are nothing other than solar sails. And then we're right back in that territory. Oh, maybe that's a technology. And now, to our case with 3I Atlas, we actually have a missing gas there, which means the situation is actually even more confusing. We have 2 points. So far, there are no signs of any cometary activity. The scientists here were eager for more observations to gain information, but none have been available so far. And then we have the topic. If 3I Atlas were a normal asteroid, then with a diameter of about 20 kilometers, it would just shoot past us, which is 100 times bigger than Oumuamua. I always pronounce it wrong, I think. Anyway, yeah. The probability that such an object or such a massive object would randomly pass through our solar system is super low, extremely low. I'd need to check the numbers again since they're even lower now. And then you have an astrodynamical hypothesis that you can actually put forward. Now let's quickly look at Jupiter. Because the hypothesis of extraterrestrial technology uses the analysis of the flight path to determine what kind of non-gravitational acceleration would be necessary to achieve certain objectives. And here, for example, this object is considered a low-thrust flight device. Of course, you could go into a bit more detail, but this is quite a controversial observation because here we have an analysis of these hypothetical maneuvers. However, this contradicts a recently published data set where just recently Elvi Loeb and his colleagues used 4,000 data points from about 230 observatories to monitor this movement. And the analysis of this highly precise data came to the conclusion that this trajectory was shaped solely by gravity. But no evidence was found for any recoil or any non-gravitational acceleration, although we actually do have that somewhere. And while there are just a few points that simply make you sit up and take notice, yeah, it makes you think. But there are definitely a few topics that I always find interesting, and 3I Atlas is definitely one of them. Of course, you could also consider looking at something like a covert maneuver at Perihelion. We had it on the 29th October 2025 when perihelion occurs on Earth's far side from the Sun. Let's briefly explain perihelion to the audience. Yes, we can do that. So we always have 2. I'll call them 2 final data points or events in covert maneuvers or in maneuvers in general. We can briefly touch on that. Maybe we should also, I'm just thinking whether I should approach this from the end or not. Give me a second. We'll talk about the perihelion again in a moment, because I actually find it quite exciting to just say, imagine you assume that someone would want to observe you. In the classic sense, and ideally, the observer doesn't want to be observed themselves. Logically, so what do? Ideally, you might hide, or you look for some kind of camouflage or something like that. And that's exactly the case here. Only instead of having camouflage, we're talking more about how this object might be able to hide somewhere. But it's not just hiding anywhere. And now I'll briefly mention the word perihelion, because perihelion is basically exactly that moment. That's why it's always fixed to a date when a planet is closest to its sun. I think the word comes from Greek. I'm not sure. It does come from Greek. Yes, that makes sense. Helios means sun. Yes, that could be it. Exactly. Imagine the planet's orbit as a slightly stretched ellipse instead of a perfect circle, since it's never perfectly circular. Then there are two distinctive points. One is the point farthest from the sun, the aphelion, and the closest point to the sun, the perihelion. Exactly. And that's kind of strange here because now we have to consider, or let's remember, that it might want to hide somewhere. We had this perihelion on the 29th October, about a week ago. And 3i Atlas reaches its perihelion, which is the closest point to the sun in its orbit, also on the 29th October. At a distance of about 1.35 to 1.40 astronomical units.
Wait, that means as Earth, we also had our perihelion on the same day.
Yeah, that's totally crazy.
That is even crazier. Okay, that's totally crazy.
That's exactly why so many people got so hyped about it. Well, you really have to say it like that. That's totally insane. And that's honestly a crucial anomaly that you just have to point out and keep an eye on. That would be exactly it. We would have perfect concealment. Exactly at the moment when 3i Atlas is closest to the sun, it will be completely hidden by the sun from Earth's perspective. So from our point of view, that's it. I think the wording was totally obscured from the Earth or something like that. It said something like that in there. And of course, you have that again. We're always a bit trapped in statistics when we speak as scientists and engineers. You have such an incredibly low probability of that happening. The probability that this occultation, assuming it happens randomly within a solar elongation of about 30 degrees, is around 5 or 6% or something like that. And then you can go ahead and say, maybe we are actually dealing with some kind of logic involving extraterrestrial intelligence here. That's exactly what this reverse solar is about. It should be called the Orbit maneuver. Maybe you've heard of it or seen it in a video. If I'm not mistaken, there was a video about it once. But why is this concealment so important for the hypothesis of an extraterrestrial intelligence? It provides the perfect opportunity for such a covert high-speed maneuver because you have an optimal braking maneuver. So the best strategy for interstellar spacecraft or for a spacecraft that intends to slow down and remain bound to the sun is exactly this reverse solar orbit maneuver. And this maneuver uses the orbit effect, which is a central concept in astrodynamics. And it basically just says that the thrust of a spacecraft is used most effectively when it is at the point of its maximum orbital velocity. So yes, that's exactly the perihelion or the periapsis, depending on the case. And that's kind of eerie when you think about it. It's just crazy.
So the whole thing, 3i Atlas is approaching. It passes really close to Venus, really close, even really, really close to Mars. 20 or 40 million kilometers, so that even a Mars rover could see it. And this Mars Reconnaissance Orbiter and also the Trace Guides Orbiter from European Space Agency, they pointed their cameras, which actually weren't even made for this, all at this object, but the Earth is avoided, funnily enough. And the whole thing, so with the Sun, Venus, Mars, and Jupiter, they get really close, but not the Earth.
As if you're deliberately making an arc around it. That's really super weird. It's just really weird. And you can definitely say it like that because it really is weird. In reality, it's always more complicated, but I don't think we need to explain that in detail. But in the astronomical context, close doesn't necessarily mean close. On a human scale, you have to be fair and say that, because even if 3i Atlas is somewhere near the orbit of Mars or reaches it, we're still talking about millions of kilometers of distance. So farther than any camera on the rover could actually resolve. And a rover like Perseverance or Curiosity, for example, is also designed for close-up shots. So typically rocks, dunes, maybe even the Martian moon Phobos in the sky or something like that. But they don't have any telescope optics inside them that could make tiny points of light visible from a great distance. Of course, Nick, you have to take that into account, but it's definitely strange. It's really very strange.
Now, about the matter, where does 3i Atlas come from? Maybe I misunderstood, but it comes with a precision of 0.6 degrees or something like that. Exactly from the direction where years ago we received the so-called wow signal. We as humanity have spread out our listeners and are constantly eavesdropping on the universe. Maybe we'll happen to hear something somewhere, some radio signal from an extraterrestrial civilization. And we've never heard anything except for that one wow signal. I don't remember when that was. That was a long time ago.
A long time ago, yeah.
A long time ago, just seconds or minutes. It comes exactly from the direction where this celestial body comes from. Exactly from there. That's where this signal came from for a few minutes or a very, very short time. And since then, just never again. Since then, silence until sometime in February, I think it was, when this asteroid or when this celestial body was discovered. Which is crazy because what are the odds that two such signals would overlap like that?
That's really something. I don't think we even want to imagine. Now, I was about to say, put it into words, but we're putting it into numbers. But yeah, that's true. I think even the wow signal was sometime in the 70s or 80s or something like that. That was a long time ago, definitely. And what I still remember, that's from Search for Extraterrestrial Intelligence. That's like this legendary signal, ultimately. Also, somehow you have this mysteriously strong radio signal whose origin was definitely somewhere outside of Earth. But maybe also, where does 3I Atlas come from? We just don't know. And we probably won't find out anytime soon where it really comes from. But that's the improbability. What makes this connection fascinating is, once again, the statistics behind it. Because the probability, as you already said, that this arrival direction of 3I Atlas randomly matches the direction of the wow signal. So I think in the paper it was titled as under 1%, and that's already, well, it's basically nothing. I think 0.5, 0.6% or something like that. So you could ultimately say that you don't have a random encounter on the cosmic dance floor here, but possibly a rendezvous or something that was prepared over decades. No idea. That's where the temporal connection is. What's especially interesting is that when the wow signal was discovered in the 70s or 80s, its source was also approaching the sun. These calculations also show that 3I Atlas, at the time when this signal was detected, was at a distance of about 0.3343 light days or so from Earth. That's actually not that far away in cosmic terms. And what I also found very exciting besides that were the sources. They also point out that the energy that would have been needed to produce such a radio signal, like the wow signal, if it had been sent from the position of 3I Atlas, it would correspond to the power of a terrestrial nuclear reactor. Well, I don't know, about a gigawatt or something like that. So, though highly speculative, this still supports the hypothesis that 3I Atlas could be more than just some rock. It adds another layer of statistical strangeness. I don't know, let's put it that way. That's definitely crazy. That's definitely crazy.
And then there's the thing about the composition. In the paper, there's actually, I think he didn't mention that in the paper, but in the podcast with Joe Rogan.
About the flowers, or do you mean about the flowers and the composition of the celestial body?
That there's so much nickel in it.
But that could be, yes.
This amount or this concentration of nickel is actually not just atypical, but completely unusual. And on Earth, we only know this from artificially produced or man-made alloys. That doesn't mean that the whole thing is made of an alloy. It just means that we haven't seen anything like this before. Such a high concentration of nickel in a comet is completely unusual.
I think that was related to iron, though. They found a lot of nickel, but apparently no iron or something. And that's what makes it so strange. Because it's exactly these laboratory hypotheses that play a role in this as well. That's a classic anomaly, right? So, a nickel-iron ratio. You know, I have to think back to my studies for that. Stop it, you have serious things going on. Actually, when it comes to chemical anomalies and the ratio of two metals in the gas plumes, that's exactly one of those points. We said there's much nickel and little iron. That also makes sense because several research teams have already found that a gas emission, and basically it should actually contain some iron as well, and we just don't have that here at all. Applying this to our 3i atlas, it gives us the same result. Lots of nickel and little iron. You could also ask, do we have an unnatural origin? This ratio is very rare in nature because nickel and iron are usually made together in exploding stars, even in supernovae. And the ratios in comets, yes, so in comets of the solar system, or rather in their composition, they show a frequency similar to that of the sun. As you mentioned, that's the industrial connection. So the only one of our known scenarios in which such a, let's call it, imbalance of high nickel to low iron occurs. The only examples are manufactured alloys that were somehow produced industrially. I think there are even a few industrial alloys in aerospace. But don't quote me on that. I'm not deep enough into it. But yes, definitely.
Yeah. And it was, well, from what I gathered, there was no plume at all, no tail. But for a while, there was actually a tail going in a completely wrong direction. So what we actually know as a comet's tail, the one that's simply trailing behind, right? And it can sometimes stretch millions of kilometers behind the actual body. And in this case, this plume also changed. On one hand, it faced the sun for a while and then simply pointed in the direction of flight.
To the sun, so to speak. So it's still completely, it couldn't get any stranger. So you have, that's really a puzzling observation. You already said that these tails that comets drag behind them are sometimes millions of kilometers long. And that's really the crucial thing about a comet. And now we have such an anti-tail, basically a jet that points toward the sun. So that's really a puzzling observation. I actually think that's great too. Well, I find that the strangest. Somehow, maybe because you can kind of imagine it visually, especially if you have a picture of it. But the most puzzling observation just appeared. So if you look at the object up close, because you have some high-resolution images, especially from Hubble, I think they were taken sometime in July 25th or so, so they're relatively new, and they showed these clear elongations, or basically a jet that it somehow splits off like a stream going in the wrong direction somewhere. And that's really very strange because a jet pointing toward the sun is incredibly unusual. Normally it's like this. Physically speaking, it's actually inconsistency. Because with ordinary comets, the tail is typically pushed away from the sun by the sun's radiation pressure and the solar wind, not toward it. Of course, you could also say optical illusion. What about that? But that's actually ruled out, let me put it that way. Comets can sometimes appear to have an anti-tail due to optical illusions. In any case, but in our case, or in the case of 3i Atlas, that was definitely not possible because the object was approaching both the Earth and the Sun from roughly the same direction. The entire tail, this elongation, was clearly visible on the sun-facing side. And this exact analysis simply shows us that the object was observed almost edge-on to our line of sight, like how you'd view a cigar along its length. And if you correct this viewing angle, so to speak, then the observation really only points to some kind of feature that somehow the count would be longer than it is wide. So a clear chat, and that just doesn't fit together at all. And that's just really weird.
Yeah, really, really, really strange, this object. Strange. Avi Loeb also estimates that, therefore, it could possibly be intelligent behavior. That doesn't mean that some green mechs all are jumping around on it, but we would too, right? We haven't sent humans to Mars either, but first we sent our probes, robots, and satellites there. And of course, it could also be the case here that an intelligent system sent this intelligent system in our direction. And yes, this very deliberate choice of trajectory, because if you wanted to try to maneuver in a solar system, you would probably choose the heaviest objects in that solar system for your maneuvers, because you could simply work much, much more energy efficiently and fuel efficiently that way. Exactly. That's why. For Avi Loeb, this suggests that this trajectory is deliberately flying so close to the sun, and also at Jupiter, because that's the second largest celestial body in our solar system after the sun. If I'm not mistaken, the sun makes up 99.8% of the sun's mass.
Anyway.
In any case, of the solar system, Jupiter makes up 0.1% of the solar system, and the rest of the solar system shares the remaining 0.1% of the mass.
What is, by the way, the perfect example of the upper effect that we briefly mentioned earlier? For those who don't plan international routes daily, this upper effect is exactly this fundamental principle that you just explained so well here. That's what this spacecraft thrust is about, but the most efficient way is to use it like this. When would you ideally like to use it? You want to use it when the maximum orbital velocity is reached. So ideally, in our case, when you're as close as possible to the perihelion at the Sun, because the Sun and Jupiter are the most massive objects, they certainly are. In our solar system, they offer a spacecraft the greatest speed advantages, meaning maximum orbital velocity, or precisely, which would theoretically also minimize the required fuel consumption, assuming, of course, that such a thing uses a conventional fuel as we know it. That's another matter, of course.
Yeah.
And for everyone who can't really judge Obert, that is,
Hermann Obert was the one who taught rocket science to Werner von Braun, basically the master, in quotes, of masters in martial arts. Not in the sense of mastering, but in the sense of learning from Werner von Braun. So just to put into perspective who Hermann Obert was, perfect, super exciting.